Welcome. I wouldn't be a good math teacher if I didn't teach compound interest that's done annually or repeatedly. It's called compounded annually or compounded at a regular interval basis. And in the next lesson, we'll learn continuously compounded. But what's really nice is this IXL explains it very well. You're going to use this formula where the A is your final amount, P is your starting amount, R is your interest rate, and it's expressed as a decimal, and the interest rate is like 20% per year. So it's the yearly interest rate. N is the number of times you accrue the interest or compound the interest. If it's only accrued once per year, then N would be 1. If it's done monthly, then N would be 12. If it's done daily, then N would be 365 days. Okay. And then T is the number of years you're going to leave your money in the savings account. So as this one, I would just write out the formula like, as I take my thing, I read the problem. It says you deposit $200 as a principal. That's your starting amount. So I'm going to go $200 or 200 times, in parentheses, 1 plus, and then you're going to earn 8% interest. Okay, 8%, we write it as a decimal, 0.08 as a decimal divided by, and this is compounded annually. Annually means yearly, so it's just going to be a 1 there, all in parentheses, raised to that, and we're going to do the balance for a total of 10 years. So I do 10 years, and again, technically I times that by 1 because that's 1 time I'm accruing interest per year. And then that is going to give us our final amount. Now you're just going to use a calculator to solve that. Now I did it one step at a time because I want to make sure that as you solve this, you actually do order of operations, right? I'm going to add inside the parentheses first. 1 plus the 0.8 is 1.08. I'm going to raise 1.8 to the 10th power. Don't multiply by 200 first. I'm multiplying 1.08 by 10. That gives me 2.158924997. I use that whole long number in my calculator, times it by 200, and I find out in 10 years I would have $431.78 because you round to the nearest cent. So all this lesson is plugging in the values they give you. So I'm going to jump. Oh, no, let's do this one. Compounded quarterly. Again, what I've done is I have taken my principal amount, put it for my starting amount. I have an interest rate of 11%. That went right here, but I wrote it as 0.11. I compounded quarterly. That means N is 4, quarterly, quarter, four times a year. So then in the top, I plugged in 4 for this N here. See, there's the N there and there's the N there. And then I did it for a total of 4 years. So I replaced the T with 4. And then I followed order of operations. 0.11 divided by 4 is 0.0275. Add that to 1. That's 1.0275. The two numbers in the exponent, 4 and 4, multiply to give you 16. 1.0275 raised to the 16th is 1.543509436. Times that by 100 and round to the nearest cent, and we get $154.35. Simply just plugging in. Now in this problem, we're going to have to use logarithms because we're going to have to find out the value of A. And if you'll notice, they don't write down the expression. So give me a minute to write down the expression and we'll walk through it. Wow, that was a very quick minute. So I've written down the equation. Now remember, it's A, your final amount, which her current balance, her final amount that she has at the moment is 600. Equals what she started with, which we don't know. That's what we want to know. She deposited initially some unknown value, times 1 plus our interest rate of 12% a year, so that's 0.12. It's compounded monthly, so that's divided by 12, and we did it for 5 years. She's been saving for 5 years, so 12 times a year for 5 years. Now I'm going to start to simplify that. So now as I work through this equation, I actually realize we do not have to do a logarithm because we take this expression 1 plus 0.12 over 12, that's 1 plus 0.01 or 1.01 raised to the 60th power is 1.8166. All we need to do is find the principal, so I divide it over. So 600 divided by the 1.8669, and I get a value of $330.27 is what she started with. But again, it's just solving an equation. It's plugging in the values we know. So if you needed to rewind and rewrite down that equation so you know what to rewrite, by all means do so. Now, this equation wasn't any harder than the previous ones. In other words, we had a principal of 300, interest rate of 10. We compounded annually, that's once a year, for 3 years. And I got the amount is 399.30. But be very careful. It says how much interest will he earn? Not how much will he have total at the end, but how much interest. If he started with $300, how much was the interest? It was only $99.30. So be very careful you read the problem and answer the question it asks. It only asks for the interest, not for the total amount. So they'll try to trick you. In other words, just be careful when you read. Now we've gotten to a problem that we're going to have to do a logarithm, because what it does is it gives us his principal amount, what he started with, that's this amount right here. It gives us the interest rate. So there's the interest rate, 0.15. It says it's compounded monthly, so that's 12 times a year. So that's our N value, 12 times a year. And it says he ended up with $12,297. That's our final amount. What it doesn't give us is how long, the time, how many years. And it asks how long was the money in the account. So the first thing I'm going to do is start simplifying this expression. So what I've done at this point is I actually added the 1 to the 0.15 divided by 12, which gave me 1.0125. Now do not multiply these two together because this exponent I have to do first, but I don't know what t is, so I can't. So what I did is I divided over the 3315. I divided the 3315 over to here. That gave me this value over here, this 3.7095. That was the 12,297 divided by the 3315. That equals the 1.0125 raised to the 12t. Now we're going to take the logarithm of both sides, either the common log or the natural. Doesn't matter which. And the reason we do the common log or a logarithm is it's going to allow me to pull this exponent right here out in front so I can actually isolate the t. So my next step, I'm going to write over here by pulling out that 12t. So as I wrote this over here, I have this log of 3.7095 equals 12t times the log of 1.025, because that 12t comes out front. Now I'm going to divide both sides of this expression. So I'm dividing this side and this side by the 12 and the log, right? That gives me the 12 log of 1.025 on this side, right? The 12 and the log, leaving the t. Now I do this in a calculator. I take the log of 3.7095 and I divide it by whatever 12 times the log of 1.0125. I get 8.7938. Now, this is not quite my answer because if you'll notice, it says round your answer to the nearest month. So I know it's 8 years and some portion of months, 12 months. So what I actually do is I'm going to type in 8 for my years, and then I multiply the 0.7938 by 12. So I do that 0.7938 by 12 to find out how many months that is. When I did that, I got 9.5. That's a horrible, wow, that's horrible. I get 9.525 something, but it says round to the nearest month. Well, 9.5, that would round up to 10 months. So I would put in 10 months. That takes some work, but you can do it. I know you can. If you have questions, I can help you with that in class. I don't think anything should get harder than this, but let me go forward and see. Yes, this one here, we don't know the interest rate, so we have to find the interest rate. So let's walk through this one. So far what I've done in order to solve for the interest rate is I plugged in my final amount, I plugged in my principal amount, I do the 1 plus, I don't know what my interest rate is. It is compounded annually, which means once per year, that's these ones, and they did it for 6 years, that's the 6. So what I first do is I divide over the 9,557. I divide this side by those two numbers to get the 1 plus r to the 6th by itself. And r over 1 is just r. 1 times 6 is just 6. So then that comes out to be 1.3059 equals 1 plus r to the 6th. Now I'm going to take the log of both sides, common log, which allows me to bring the 6 out in front. So at the moment, I'm just going to have this log equaling the log of 1.3059 divided by 6, which when I divide both sides by 6, I get 0.1932 ... equals log base 10, because it's the common log, of 1 plus r. So again, what I've done is I've actually taken the log of this 1.3059, which was 0.11592 something, divided by 6, and got this 0.193. Now what I'm going to do is, remember, this is base 10. So I'm going to take 10, raise it to the 0.1932, and that's going to equal 1 plus r. So I'm kind of worked back this way. So let's find out what 10 raised to that power is. I get 1.0454 is equal to 1 plus r. And then I minus the 1 over, so minus the 1 from this, and we're left with just the decimal, which is 0.0454, but it says round your answer to the nearest tenth of a percent. Now we got to make sure we move the decimal twice, so it's 4 point, nearest tenth, that's this one, 5, I don't go up because that's a 4.5% interest rate is what she was making. So that's what I type in, 4.5% interest rate. Again, take some work. If you need to rewind and watch that slowly, by all means do so. If you have questions or concerns, please do bring them to class.